Now that the belt is deformed, we can link it into the system. Now we actually have two sets of items to link in. We have the pulleys and then we have the belt. So we're going to start with the pulleys. Now the first pulley is pretty simple. It is basically just connected to this gear through the common axle. So all we have to do to make this rotate in sync with it is to connect it. Now we can do this in the connection editor. We can create an expression or we can do a constraint. Let's go ahead and do a constraint to see how that works. So I'm going to go ahead and select gear 48 and then select pulley A. We're going to do a constraint and then do an orient constraint and make sure maintain offset and constraint axis all is turned on. Now what this does is it basically just connects the rotation of one to the other without having to do a hierarchy. So now when I rotate that flywheel, everything moves into place. So now this second pulley is going to move in relation to the first. Now this relation is going to be very similar to what we saw with gears. In a gear, the number of teeth will determine how fast one moves with respect to the other. But we don't have teeth for the pulleys. So we need to use the relationship of their diameters or their circumferences. So basically the physical size of each will determine that. So how do we figure out how big these are? Well, the easiest way is to just measure the diameter of these, and that will determine the ratio. So I'm going to go ahead and turn off the gears so we can see this a little bit better. And then I'm going to go into a front viewport. Now what I'm going to do is I'm going to measure the diameter that the pulley is affecting. Not the flange diameter, but the actual place where the belt is driving the pulley. So we can do that using our measurement tools. So if we go into Create, we have Measure Tools. We have one called Distance Tool. So I'm just going to go ahead and click from the center of where I think the belt is to the opposite side center, and it gives me a dimension. So that's my first dimension right there. So now all I have to do is do the same for the second one. Do Create, Measure Tools, Distance Tools. I'm going to go from about here to about here. And so now I have two distances. And these distances inform me as to the relationship of the diameter of one to the other. So all I have to do is use that to create a ratio. So I'm going to go ahead and select both of these, and we're going to create basically the same expression we did with the gears. So I'm going to go into Windows, Animation Editor's Expression Editor. And this pulley B is driven by pulley A. And as with everything else, it's rotate Z that is affected. So I'm going to create a pulley B.rotate Z is going to equal pulley A.rotate Z times its diameter, which is 5.3, divided by this diameter, which is 13.14. Now, the one thing that is different with pulleys is that they are both working in the same direction. So with a gear, when one connects the other, it reverses the direction of the connected gear. So I don't need to put the negative sign in front of it. This expression should hold. Hit Create. So now that I have this, I should be able to rotate one and have everything move as usual. So now everything rotates along with that crankshaft and the gears that drive it. So now we have the pulleys in place. And remember, it's really just the ratio of their diameters that determines the rotational rate.